What's going on, guys? Lesson number 5, the last one, last page of your homework. We're going to knock this out. Segments A, B, D, C, and EC intersect at point C. So we got all these lines coming together at this intersection. And what we're trying to do here is we're trying to find these x's, and we know that this big obtuse angle in the center, 148, is is given to us. So we know that this one right here from blue to blue is 148. We should notice to find x that we've got a straight line. So we can write a very simple equation to help us solve this. We know that if we take x, this x here, plus this x over here, plus the 148 that's in that big angle in the middle, since they all lie on that straight line, they're supplementary. So they should have a sum that equals 180 degrees. Simplifying that with a little bit of algebra, 2x's plus 148 equal 180. If this was a tape diagram, it would look like this. We have a total of 180 degrees in our supplementary angle. 148 of them have been used on this big honking one in the middle. But we have two little bitty X ones on the side that we have to find the size of. So what we got to do is we got to knock this 148 out first. So when we take the 148 off, let's count up to 180. 2 more gives me 150. 30 more gives me from 150 to 180. So I know that the two X's are going to be worth their difference, right? When we knock that 148 off, we're finding out how long the two X's are worth. So that gives me 32, right? So we know that that's 32. And if I take two things and I split them up among a total of 32, then each one is worth 16 degrees. We know that X is equal to 16 degrees for number 1. All right. So you can see how this one's a little bit more complicated, but it is not impossible for you guys to figure out. Okay. Show that work, set up that equation, find that missing value. Number 2, line L is perpendicular to line M. That is code for, guess what? L and M form right angles. So we know that this is right, and we also know that everything over here on the right side is a right angle. Although I'm not going to draw it in there because it might confuse us a little bit whenever I start working this out. So that is leaning me toward a complementary relationship because I know that everything in this corner that I'm highlighting in blue over here, I know that everything inside of that is complementary. So it all adds up to 90. So I can write an equation for it. And the equation would be, okay, every angle inside, 19 plus x plus w equals 90 degrees. I know that that is true. Okay. Now, the problem with this equation that we wrote is we haven't really figured out a way to solve an equation that has two variables. So it would be nice if we could find out what the size of another one is. Well, you got to go back to the picture to figure this part of it out. So let's go back to the picture and let's see, the X is kind of in there in the middle. There's not really a lot going on vertically with it. But if you look really closely, this 138 is there for a reason. It is a very helpful number. It is on a straight line with the W that we need to know, right? See how it's on that straight line? So this tells me that W plus 138, since they're on a straight line, they are supplementary. They're going to have a total of 180 as their sum. So I kind of have to do a two-step equation setup here. I've got to solve this one, and then I got to plug in what I get for that and solve it over here. So over here, I can just simply subtract to find out that W will be their difference because it's the leftovers. Count up, 2 makes 40, and 40 more would get me to 180. So W equals 42 when I subtract these two. And I can plug that in my equation that I wrote originally as I was trying to figure out what X was and W. So we know that W is 42. So that's part of our task from the problem. Find the value of X and W. But now we can use W being 42 as part of our solution process in the next one. So we know that 19 plus x plus, we know w is now 42, and 90 is the total. And all of these are degrees, so I'm not even going to put the symbol there. 19 and 42 are like terms. If you add them together, let's do a little rearranging. I've got the space. Why not? I'm going to rearrange with commutative property. Everything is positive, so peachy. 52 plus 9 would be 61. Let me double check that in my brain. 61 plus x. Yes, that makes sense. Equals 90. And then to find out what x is, I need to subtract 90, the total, minus 61. Count up. 9 gets me to 70. 20 more, 29 degrees. So x is equal to 29 degrees, and w is equal to 42. If this was 29 and this was 42, let's see if it works. 19 plus 29 plus 42. All right. If we add all of the ones places together, that's 18 plus 2, that's 20. So 0, carry the 2. 2, 3, 4, 5, plus 4, 90. They all add up to 90, which is proper because that blue corner is 90 degrees. So that's a good way to check. And 42 and 138 make 180. Everything works. Everything goes in the space that it's supposed to. Let's go on to number 3 with the runners. So this is throwback problems to some previous things that we have learned how to do. And as soon as I started reading this problem, my mind is already thinking table. A runner is running at a speed. We got distance. We got time in minutes. We got all this stuff. So let's just go ahead and set up the table. And let's ask and let's sketch through the problem and see, okay, what are the things that are going to go on my table? Well, clearly, we're going to have kilometers. Oh, I saw minutes. I like putting minutes on the left of my tables. I like time on the left because that's usually where X goes. And then kilometers are on the right. And I know that this runner can go 2/3 of a 5K race in 21 minutes. So what I'm going to write down is 21 under minutes. And kilometers, I'm going to write 2/3 of 5. They kind of gave it to me in a weird situation, but we might have to convert that here in a second. We'll see. They ran the entire race at a constant speed. So the question is, how long did it take to run the entire race? So 21 minutes to do 2/3 of 5. So the question is, how long will it take them to do 5 all together? So that's really what we're looking for here. So I'm going to grab a calculator. I'm off screen. I'm back. Okay, so my calculator is going to help me with finding out what 2/3 of 5 is. I don't know why I grabbed my calculator. That's dumb. 2/3 times 5. I'm a math teacher, for God's sake. I should be able to multiply numbers. 2 times 5 is 10, and 3 times 1 is 3. So instead of writing 2/3 of 5, I'm going to use my magic eraser here. I'm going to cut you out. And I'm going to rewrite it as 10/3 because that is the number that we're going to work with here. Okay, so 10/3. That's my relationship. I want to know what this is going to be when I run the full 5 kilometers, not 10/3 of it. So I need my constant of proportionality. I got to do 10/3 divided by 21 to be able to find that. Divided by. So I'm going to do a little keep, change, flip action. Keep, change, flip. All right. And I'm going to get 10 over 3 times 21, which is 63. All right. So there's my constant of proportionality. Whammo, times 10 63rds. But I actually need to convert this the other direction. So I need to multiply and come back. And to come back, you can multiply by your reciprocal. So I'm going to multiply by 63 over 10 when I come back. So to get my answer, I've got to do 5 times 63 tenths. 5 times 63 over 10. All right, finally got something that will reduce 1 and 2. So my answer is 63 halves. Half of 63 would be 30 and 31 and a half. So it's going to take me 31 and a half minutes to finish this race if it took me 21 minutes to do 2/3 of it. So there's my answer there for the first part, 31.5 minutes. How many minutes did it take to run a kilometer? Well, that's going to be our constant of proportionality, which is, let's see, how many minutes did it take to run a kilometer? So when this is 1 kilometer, we go back this way, 1 times 63 tenths. So our answer would be 63 tenths or 6.3 minutes. That would be the answer for that one. I like 6.3 better there. Not very many people are like, hey, how long did it take you to run 63 tenths of a minute there, buckaroo? No, 6.3 makes a little bit more sense there. Let's move on to the last one. I'm killing all kinds of time being stupid. Jada, Elena, and Lynn walked a total of 37 miles last week, all together. Jada walked 4 more miles than Elena, and Lynn walked 2 more miles than Jada. The diagram below represents the situation. Okay, so here we go. What we got going on? Elena, Jada, and Lynn, all right, all walked 37 miles all together. Okay. Elena, we'll call her M, right? So that's how far she walked last week. Jada was 4 miles more than her, so M plus 4. And then Lynn was 2 miles more than Jada, so you can see why we tacked on 2 on top of what Jada did. So we're going to find the number of miles that they each walked and explain or show our work. So in this total of 37, we have 1, 2, 3 M's plus 2 4's, which makes 8, and then a 2. And all of that together equals 37. So like terms, 8 and 2, 3M plus 10 equals 37. And just solve the equation. We need to knock that 10 out, right? So think of like knocking this 10 out, right? If that 10 goes away, the 3M's are worth 10 less than this. So if that's gone, this is 27. And what number times 3 is 27? You guessed it. Ding, 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 ding. Give them a prize, Johnny. They win. 9 is the solution. Explain, or I'm a fan of showing my reasoning, which is why I showed my work over here. And we're done. We're finished. Homework done. You guys have a great rest of the week, and good luck on your quiz this Friday.